Hey guys, and welcome back to another video on the channel. In today's video we're going to be pretty much explaining how to sketch a complex subset in the complex plane on an Argand diagram. Okay, so this appears pretty much in year 12 specialist and a little bit in year 11 with complex numbers chapters. And we pretty much have to sketch this subset here. So basically this is saying you have to sketch this in the complex plane of pretty much this thing here. So what we do straight away is we've got to know that a complex number, z, takes on the form x plus yi. Okay, that is the general form of a complex number, a real number plus an imaginary unit. Now, on our Gann diagram, we have the imaginary axis as your y-axis and the real axis pretty much as your x-axis. So it only makes sense that we associate x with this and we associate y with this. Okay, so getting that set up is probably the most important thing. Okay, now all we have to do when you're sketching a subset in the complex plane is you've just got to look at this stuff here. Okay, ignore the rest of it. The rest of that stuff there is pretty much saying, all right, this is the set, all the complex numbers that obey pretty much this. Okay, and there it might be a circle, might be a line, etc. Okay, so all we got to do is pretty much just write this. So square root of 3 modulus of z minus 1 equals modulus of z plus 1. Then we're just going to substitute x plus yi into wherever z appears. Okay, so we have the square root of 3 modulus, and we have x plus yi minus 1 equals x plus yi plus 1. Now we've got to group the real and imaginary terms. Okay, so we can see here those are real terms, and we can also see here those are also real terms. So you have to rewrite them so they're pretty much grouped together because we're going to have to take the length of these complex numbers very shortly. So we'd have x minus 1 plus yi, and then we have x plus 1 plus yi. Now, this thing on the outside is basically asking, all right, what's the length of this complex number here? Now, if we just think of a regular complex number without any variables, we have, let's say we had 4 plus 3i. If you're finding the length of this thing here, it's pretty much just like a vector. You're pretty much doing Pythagoras' theorem. So you have 4 squared plus 3 squared. Now you don't include the I because on an Argand diagram, that's actually built into its axis, like the imaginary axis. Literally is saying, all right, this is I, this is 2i, so you don't need to include that when taking the length. It's like with a vector, if you had, like, let's say the vector A is 2i plus 3j, when you take the length of that, you're not including the I and the j. You're just pretty much doing this operation here. We have 2 squared plus 3 squared. You're not including those. Okay? Right, so now we've got that out the way. What we do here is pretty much we take the length of pretty much these complex numbers. So the modulus basically says, if you modulus x, you basically have to do square root it and square it at the same time. Okay, so it basically makes it all positive. Another way to think about it is just pretty much find the length of this stuff here. So we would have the square root 3. Now you would have a square root around this whole thing, but you would square these individually because you're taking a length. So it'd be x minus 1 squared plus y squared equals square root of x plus 1 squared plus y squared. Now what we can do next is, because there's a multiplication here, we can basically square this entire side here and square this entire side here to get rid of that square root. Okay, then we have this 3, so this 3 can multiply by this stuff here. Okay, and then this side would just be x plus 1 squared plus y squared. Okay, don't need a bracket there. I could probably distribute the 3 here, so we have 3 of x minus 1 squared plus 3y squared equals x plus 1 squared plus y squared. Now we're probably going to get a circle here, but we want to put it in the form of, like, let's say x minus h squared plus y minus k squared equals r squared. So we can read it pretty well and sketch this subset quite easily. Alright, so what we're going to do is, first of all, we're going to expand this and this. So this would give you 3, and then this would turn into x squared minus 2x plus 1 plus 3 squared equals, this will turn into x squared plus 2x plus 1 plus y squared. Distribute that 3, so we have 3x squared minus 6x plus 3 plus 3y squared equals x squared plus 2x plus 1 plus y squared. Now we look for anything in common that we can group up. So we can see that's a like term with that. We can also see that's a like term with that. And we can finally also see that that's a like term with that. The rest of them are just constants. So I'm going to move all the constants to this side here. So I'm going to minus 3 on both sides. And then I'm going to minus the x squared here. I'm also going to minus the 2x here. And then finally I'm going to minus that y squared. Okay. So if we do this, we're going to have 2x squared minus 8x plus, that would be 2y squared. That's gone, that's gone, that's gone, that's gone. This should be negative 2 then, and that's gone, that's gone. And this is what we'd have left, if I've done everything correctly. Now we can see they all are divisible by 2, so we can divide the entire thing by 2. So we'd have x squared minus 4x plus y squared equals negative 1. Now what we want to do is we want to complete the square on pretty much this term here, because we've almost got it in this form here where you can almost read what our coordinates is. We just can't read the x coordinate. Okay. So what we can do is complete the square here. So divide the middle term by 2 and then square it. So that gives you 4, I believe. Yeah, because negative 2. Yeah, gotcha. And then you plus the 4 and then you add the minus the 4. So we'd have x squared minus 4x plus 4 minus 4. And that gives you a perfect square there. So this can be rewritten as just x minus 2 all squared plus y squared minus 4 equals negative 1. We then finally can move the 4 to the other side. So we just go plus 4, and now we get this. So we have x minus 2 squared plus y squared equals positive 3. So this is a circle. The circle has a center at positive 2, 0, and has a radius of the square root of 3. So if we were to think about this circle here, it only has been shifted to the right by 2. So it's gone over here. And it looks something like this. Now it won't go past here because the square root of 3 is less than 2. It's about 1.7. But this is what it kind of would look like, where you got that radius of square root of 3. Okay. I think there's a nicer picture on it somewhere here. I'll see if I can pull it up. Give me 1 second. Oh, here we go. This is what it looks like. Alright, so this is what it would look like in a book. If it loads, hopefully you can see that picture. So this is what our set looks like. So this is every complex number here. This is the subset that we've just sketched there. Okay. If you had an inequality, you would either have a shaded region in here or the outside. It doesn't really matter. It has to pretty much be specified. Now, because they didn't have an inequality, it's just those complex numbers on that, if you will, circumference. Okay. But that's how you sketch this subset. I hope you enjoyed this video and I hope you found it useful to you. I'll see you in the next one.